So if you want a little phrase here, polygons, polys meet parallel lines. This is kind of like a polys meet, sorry, I should just say meet parallel lines. So it's kind of like a catchy title to this, so that it's not that catchy. Yeah, no, sorry. That's the best I could muster right now. But that it's a mix between those, right? So we're going to show if AB is parallel to CD. A reminder, to prove lines are parallel, what do you need? You need to show me that one of these is true, right? One of these is true. And I'm just going to give you a short version of this. You need to either show me that alternate interior angles are congruent, alternate exterior angles are congruent, corresponding are congruent, or CIAs are equal to 180. Okay? That's how you prove lines are parallel. You need to show me that one of these is true, and then you're good to go. I'm going to tell you that my favorite is CIAs. Okay, that's my go-to. It makes it easier with polygons in particular. I don't know what I should say here. It doesn't matter, but this one is the preferred one, specifically when it comes to polygons. Okay? So let's look at our polygon here. When you see a polygon, you start counting the sides, guys. That's the first step. So this is a pentagon, right? So 1, 2, 3, 4, 5. So n is equal to 5. So my goal is going to be this. I'll be plain and simple here. I will try to find this angle, and I will try to find that angle. And we know that these are CIAs. But we don't know whether or not they're going to add up to 180. We don't know that yet, so we're going to solve that. So I'm going to call this X and Y. Just assign it letters so that it's easier for you to work with. Can we find X? What kind of angle is X right now in this context? Interior? Okay, let's find it. X is 5 minus 2 times 180 divided by 5. Angle X is 3 times 180 divided by 5. Angle X is 108, right? Next, how can we find angle Y? We don't know lines are parallel, guys, so you can't just go 180 minus 108 and just assign it. We have to prove this on its own merit. What do we call this dashed line here from corner to corner? Right? Like we have a diagonal. And so what kind of inscribed shape do we have here? Trapezoid, right? It's a trapezoid. We know at this point that this is 108 and this is 108. Okay? This is Y. So angle Y is going to be 360 minus 2 times 108. You have this formula, right? You have this formula for inscribed trapezoid. We divide it by 2. Please do the top first. Don't do it all in one shot. You're going to get the wrong answer unless you put brackets around it. But that's 144 divided by 2. Angle Y is equal to 72. So these two are important. And I will say that angle X plus angle Y are equal to 108 plus 72. That's 180 degrees. So you check that. You're like, okay, they're adding up to 180. Angle X and angle Y are consecutive interior angles. Therefore, AB is parallel to CD. So you show me that they add up to 180. You tell me that they have a name, so you can say that AB is parallel to CD. So we're combining everything we've learned so far with these shapes here. So if you want more of these, I'm going to say this. The examples I give you are maybe a little tricky. If you are comfortable with something like this, you should be fine on the test, right? So I'll say this, try 47 to 48. 47 to 48 if you want more practice. Can I just talk about this one real quick? What are B and C here? What do we call these two? Alternate interior. So you're gonna want to show that B is the same as C, right? Somehow. And so you might want to find angles all around it to get you there. Look at that. There's a trapezoid there. Right? There's a pentagon there. You can do the whole thing, subtract A from it. Get creative. You'll find out how to do that if you just apply yourself. And maybe skip this one. I think the back has some that aren't as busy, right? So try that. But that's it for now. I can show you the key maybe quickly on the screen so you can actually gets quite busy. I start with the interior angle. So we know that all of these are 128.57. Then I work with this trapezoid. And remember, when you find the base angle of the trapezoids, you're finding both of these base angles. There's an inscribed triangle, you can find A. And then I find this angle here. Knowing that all of this is one interior angle, I just subtract A and this angle from it to get C. It happens to be the same, right? Almost the same, 0.42 instead of 0.43. We still consider things the same in this instance, okay? So give that one a try. I'm going to leave this up.